Example 3, here we go. A 216 meter square rectangular pea patch is enclosed by a fence and divided into 2 equal parts by a fence parallel to one of the sides. Okay, so rectangular, so what you want to do is draw that out. And it's telling us that this whole thing has an area of 216 meters square. Now, in addition, it said it's divided into 2 equal parts by a fence parallel to one of the sides. So students, you can divide it like this, or you can divide it horizontally like this. It doesn't matter how you divide this. You can just divide it however you want. All right, I'm just gonna divide this vertically up and down. So I am going to divide just like that. We know that the area is 216 meters square. Okay, what dimensions for the outer rectangle will be required smallest total length of fence? How much fence will be needed? So I'm looking for the smallest fence here. So fence meaning I'm gonna have a perimeter, so I would need to go in and label some things, right? I'm gonna call the base B. I'm gonna call the height or base and length and width. However, let's do width. Okay. So area, students, is gonna be base times width. Okay. Perimeter, I'm gonna have 2 widths plus 2 base, okay? But because of this extra fence here right in the middle, that's an additional width. So really, that's 3 widths. So now perimeter is 3 widths plus 2 base. All right, guys? Now, just like all other previous questions, you guys have to rewrite your equation with respect to one variable. Let's do W. So 3W plus 2, and we need to find this base. Well, we have this area formula over here. I'm looking for base, so I'm going to divide both sides by W. Base is 216 divided by W. We are going to substitute this in, 216 divided by W. So P of W equals 3W plus 216 times 2, 432 over W. Okay. I'm going to do the first derivative. I'm going to use the power rule. So P prime of W equals 3 plus, this is the same as 432W to the negative 1. So minus 1 W minus, 1 times 432 W to the negative 2. And from there, we are going to set it equal to 0 to see if we can solve for our critical point. Okay, I'm going to make it into a common denominator of W squared. So 0 equals 3W squared minus 432 all over W squared. Well, W represents your width. So the first, number one, you can't have a 0 width. If you have a 0 width, you won't be able to find, you won't be able to make a rectangle. So right now, your domain, students, must be bigger than 0, okay? But this right here can't be 0. But anyway, it doesn't matter for us anyway, because we are not going to use that in this particular application. But we can use the top and solve for 0. Okay, move 432 over to the left. Divide both sides by 3. And so we are going to get 144 equals W squared. Square root both sides. Normally I'm going to say, don't forget to write plus or minus, but we can't have a negative based on our width restriction. So right now, our width is 12 units. What was the unit? Meters. We are going to plug it in to get our base. So base is 216 divided by 12. 216 divided by 12. 18 meters, okay? We are looking for the smallest length, the smallest total length of the fence. So we are going to add them up together. So take this formula and plug in all of your bases and your width. So P equals, we have 3W, so 3 times 12, and then we got 2 bases. Each base was 18, so 18 times 2 plus 3 times 12, that's going to give us 72 meters. So let's write a complete sentence with all of these parts. You guys ready? The smallest total length to be used is 72 meters with dimensions. Let's see, it's looking for dimension 2 as well. Yep, what dimensions? With outer dimensions of 12 meters by 18 meters. Box that up. All right, guys, here we go. A farmer with 2,000 meters of fencing wants to enclose a rectangular plot that borders on a straight highway. If the farmer does not fence the side along the highway, what dimensions will be enclosed? What dimension will enclose the largest area? What is the largest area that can be enclosed? So you guys can see that all of these questions, they have a common theme, right? We're looking for the optimal amount. We have 2,000 meters. So I'm going to label my rectangle here. Base and width. If it's 2,000 meters, that is going to represent your fencing, and that is going to represent your perimeter. Excuse me. So 2,000 equals 2W plus 2 bases, all right? Now it says, oh, you know what? Don't do that, because it says here, I have a highway that I am not enclosing. Whoa. So students, I only have 1 base, all right? So 2W plus 1 base. The farmer does not fence a site along the highway. What dimension will enclose the largest area? So we are going to do area equals base times width. We are going to write it with respect to, I'm going to write it with respect to W. So I'm going to replace my base and keep my W. So over here, I'm going to solve for base by moving 2W over. So 2,000 minus 2W equals a base. Put it over here. So 2,000 minus 2W. I am going to take the derivative to find the critical points, but for me this time it's easier to distribute and use the power rule. Okay, so here we go. A prime with respect to W is just 2,000 minus 4W. Solve for it, so move 4W, set it equal to 0, sorry. Move the 4W over here. Okay, so divide both sides by 4. I'm gonna have, ooh, W, oh, come on, it's frozen, sorry. W equals 500, excuse me. All right, guys, W equals 500. I'm gonna go 2,000 minus 2 times 500. That should give me my base. So 2,000 minus 1,000. So my base comes out to be 1,000 meters, okay? This is all meters. And it's looking for the largest area. So we have the base, we have the width. Area equals 500 times 1,000. So area equals 1, 2, 3, 4, 5. 5 zeros. 1, 2, 3, 4, 5. So 500,000 meters square. So let's write that out, guys. The largest area is 500,000 meters square with dimensions of 500 meters by 1,000 meters. Box that up. Example 4a. The height of an object moving vertically given by negative 16t squared plus 96t plus 112. with s in feet and t in seconds. Find part A, the object's velocity. Excuse me, guys. When t equals to 0. And part B, find the maximum height when it occurs. And C, when the position is 0, find its velocity. All right, so we are given position is negative 16t squared plus 96t plus 112, and it is measured in feet, and time is in seconds, okay? Part A says find the velocity when time is 0. So we want to find the derivative of position, which is negative 32t plus 96. And then plug in 0 because it's asking for time equals to 0. So if I plug in 0 for time, we are going to have 96 feet per second. So the velocity when t equals 0 is 96 feet per second. This means it's the speed, okay? Velocity is very similar to speed, except velocity has direction. Since this is positive, we know that this is going to the right. So velocity when we start out is 96 feet per second, okay? Then part B says, find its maximum height and when it happens, when it occurs. So B, maximum height, students, it's at the vertex. Well, vertex is when velocity must equal to 0, because that's when the horizontal tangent is. We already have the velocity, which is negative 32t plus 96. We are going to set equal to 0. Move 32 to the right, so that's going to be positive. Divide both sides by 32. T is going to be 96 over 32, which is going to be 3. Now that's the time. Look, it's looking for when it occurs and what is the maximum height. To find the maximum height, we have to plug it back in the s of 3. So s of 3 is negative 16, 3 squared plus 96 times 3 plus 112. With all of our basic math, it's gonna be 256 feet, okay? So the maximum height, of the object is 256 feet, and it occurs at 3 seconds. All right, then we have to go and answer part C. Find its velocity when position is 0. All right, so we gotta go and position equation is negative 16t squared plus 96t plus 112. Now, student, position equaling to 0, meaning that when it starts or when it landed, right? So we are going to see if we can factor this out. Looks like I can take out a negative 16, okay? If that's the case, this is now positive, this is now negative 6t, this is now also negative. Then negative 16 equals to 0, that doesn't make sense, so I'm going to factor these out. This is t minus 7, t plus 1. So t equals 7 and t equals negative 1. Well, the negative 1 for time, that's not going to make sense. So the position is 0, meaning that this is now when it landed. All right, guys. So when it landed, let's check out the velocity, because now we have to plug it back in. Velocity of 7. The velocity equation was, it was here. Okay, so negative 32 times 7 plus 96. So velocity when this object is landing is negative 128 feet per second. All right, so that makes sense because it went up. So let's talk about this really quickly. This right here is the velocity when it went up at time equals to 0, which explain why it was positive. It was positive 96. I'm sorry, positive 96. No, that's not the one. Sorry, this one up here. Velocity equals to 0. So when it went up, the velocity is positive because it was going upward of 96 feet per second. Now it was landing in 7 seconds, so that's why when the velocity is negative. So the velocity when the object was landing at t equals 7 seconds is negative 128 feet per second. Right? So again, velocity can be negative. Let's go to example 4b. The height of an object moving vertically is when it's given by s equals negative 12t squared plus 16t plus 72 with s in feet and t in seconds. So very similar. Find part A. I'm going to ask you guys to do that for me and then write out a complete sentence. So find part A, the object's velocity when t equals to 0. Please work that out. Let me know what the answer is. Show me all the work. Write a complete sentence. And then part B, similarly, I want you to work that out. So A, B, and then part C, find the velocity when the position again is at 0. And again, position at 0 is when it's landing, or if it could also when it goes up. Okay, but part A already asked when t equals to 0. So well, sometimes you can start the object at time equals to 0, and that is not at 0. So right now it's at 72. So this object, it's at 72 feet when it starts. So when the position is at 0, you're not going to have a time equals to 0. All right, guys, so work that out. Write yourself a complete sentence, and then we'll check that later. Okay, guys, so maximum profit, if any, occurs at a production level at which marginal revenue equals marginal cost. Okay, and you guys remember marginal revenue, that's the derivative, so is marginal cost. So let me give you a graph here so you can have a better understanding. So y is going to be money, and then x is going to be units of production. Okay. Normally costs, you would definitely start out higher, right? And then the more you produce, the less cost is going to be until a certain point. And then revenue, let me label this. Cost is blue. All right, revenue, you're gonna start out with, you're not gonna make as much money at the beginning, but then eventually you're gonna make more and more and more. Okay, so there's your revenue in red. So marginal revenue, meaning that you're gonna take the derivative, and hopefully I'm sketching this out correctly, at a level where the derivative of these two are equal, then that's when you're gonna make the most money. So here is when you're gonna make the most money here, right? When the cost is below the revenue, but the derivative are equal. So here is your max profit. It's when the derivative of cost equals the derivative of your revenue. Now this is where your break-even point is, when the cost break even. The cost equals the revenue. All right, guys. Suppose that the revenue equation is 9x and the cost equation is x to the third minus 6x squared plus 15x. where X represents thousands of units, so that's kind of important, thousands of units. Is there a production level that maximizes profit? If so, what is it? Okay, so to maximize profit, we are going to try to do the derivative of the revenue, which is 9, and the marginal cost equation, which is the derivative of cost. So 3x squared minus 12x plus 15. And based on your rule, we are going to set these equal to each other. Subtract 9 from both sides, so 0 equal 3x squared minus 12x, and then plus 6. Looks like we can reduce everything by 3. Okay, so divide each and every term by 3 just to make your number easier to see if we can factor it out. So minus 4x and then plus 2. Well, that is definitely not factorable. So quadratic formula we go. X equals negative b. B is 4. So b is negative 4. So negative of negative is positive 4. Plus or minus square root b squared. So negative 4 squared is 16. Minus 4 times a. A is 1. C is 2. All over 2 times 1. X equals 4 plus or minus under the square root. That should be 8 all over 2. So we should have two equations, okay, 4 plus or minus rad 8, 4 plus rad 8, all over 2, and then 4 minus rad 8, all over 2. Yes, we must simplify that out, so that's going to be 2 plus rad 2, this is 2 minus rad 2, and just kind of giving you a decimal. So this is about 3.14, and this is about 0.59. Now guys, excuse me, based on our definition, right, we have two x values here, but remember the first x is going to give you the largest, right, the maximum loss amount. So I'm gonna graph this out really quickly so you guys can see it as well. Okay, so here I have the revenue is 9x, which is in red, and then the cost is in blue. I'm moving it up really quickly here. Obviously we can't have negative units for production, and we can't have negative, well, technically we can have negative money. So what's happening is I'm going to pinch it in so you can see this. Okay, we have a break-even point right about here. That's your break-even point. Now can you see here on when x is less than 1.268, remember this is in thousands, okay, of units. So that's going to be, the revenue is below. So that's why when we solve for it, we have an x value of 0.59, which is somewhere over here. Let's try to see where we, 0.59, right there. So that's going to be when you will lose the most money. And then we solve for the other one. And it says 3.4 and some change, 3.4. So this is when you will make the most money because you have a revenue that's above the cost. So I'm trying to move it down. Around here. It won't let me move. Okay. So around there. So this is when you're going to have the most money, when you're going to make the most money. So that's why when you have two x's, when you solve for it, you have two x's, just be mindful. And then obviously you know that the most money that you're going to make is the later, the bigger the x. So let's write our complete sentence here. The max profit is when the production level is, we need to move it 3 decimal places. So 1, 2, 3. So that's going to be 3,410 units. And I said, if so, what is it, right? So we already wrote down the units. Okay, this one's very similar. I'm giving you revenue, I'm giving you cost. X again is in thousands of units. And I'm looking for, is there a production level? Okay, that means looking for X that maximizes profit. So let's do R prime, which is 6. Then you're going to do C prime of X, which is 2x minus 4. We set them equal to each other. add the 4 over, so 10 equals 2x. X is going to be 5. Oh man, there's only one location. Okay, but this is a unique model. So we only have one, and yes, that is the units that would be the required production level that will maximize profit. But how, right, it's kind of difficult to see. So I'm going to show you again. I've already graphed it out. So based on this, students, we have 2 locations that will have a break-even point. Now, this is a unique model that when you start out, you make a profit right away. So can you see that? Let's find 5. Where is 5? 5 is somewhere here. Okay, so around 5,000 units, can you see the revenue is above the cost here? So around 5,000 units, this is when we make money right away. Now, but this is, again, a unique model. The more we make, or the more units we produce, the more looks like we will lose because the revenue gets below, the revenue graph gets below the cost, and the costs increase exponentially more. So this is a unique model where you start out making profit right away. Let's go back. Okay, so we have an X value. We do have the max profit. So max profit is when 5,000 units are made or produced, okay? All right, definition for minimizing average cost. So if the average cost can be minimized, sorry, I'm missing minimize, it will be a production level at which the marginal cost has to be exactly the same as the average cost. Okay, so this is marginal cost, and this is average cost. Okay, all right. Example 6a. Suppose c of x equals x to the third minus 20x squared plus 20,000x is the cost of manufacturing x items. Find a production level, which is x, that will minimize the average cost of making x items. So the formula for minimizing average cost, students, is the average cost has to equal to the derivative of the cost function. So from here, let's find the derivative of the function, okay? So c prime of x equals, this should give us 3x squared minus 40x plus 20,000, okay? Now we have to also find the average cost, which means we are going to take the function and then divide it by x. Well, your function is x to the third minus 20x squared plus 20,000 x, and then we're just going to reduce the x. So now we have x squared minus 20x plus 20,000. These two equations, we are now going to set them equal to each other and then try to solve for x. So 3x squared minus 40x plus 20,000 equals to your average cost equation, which is x squared minus 20x plus 20,000. As you can see here, the 20,000s will cancel each other out. So I'm going to move it over and then see if we can factor. So subtract x squared over, so we are going to end up with 2x squared. Add 20x, and now I'm just going to have 20x left, equal to 0. Looks like I can factor out a common factor of 2x. If that's the case, I have x minus 10 left. Take each factor and set equals to 0. So 2x equals to 0. X minus 10 equals to 0, so I'm going to end up with 0 here, and then over here I have 10. For this particular context, it does not make sense, right, to produce 0 items. So to minimize average cost, students, this company would need to produce 10 items, okay? So to minimize average cost, 10 items would need to be made. Box that up. All right, let's go and try example B. Suppose the cost function is now x to the third minus 6x squared plus 15x, where x is now representing thousands of units. Is there a production level that minimizes average cost? If so, what is it? Okay, guys, so we want to take the marginal cost and set it equal to the average cost. So c prime of x is 3x squared minus 12x plus 15. Average cost, students, is we're going to take the original function, x to the third minus 6x squared plus 15x, and divide by x. That will reduce down to x squared minus 6x plus 15. Take these two and set them equal to each other. So that's 3x squared minus 12x plus 15 equals x squared minus 6x plus 15. The 15 will cancel. Move the x squared over, so we have 2x squared. Add 6x's to both sides. That's 6x equals to 0. Looks like we can factor out a common factor of a 2x. So we're going to end up with x. Ooh, sorry. This is a minus 6. So x minus 6. So 2x equals to 0, x is going to come out to be 0, and again, it doesn't make sense to make 0 items, right? So we can, in this context, we can ignore 0. Then we're going to solve for x over here. We have x equal to 6. So as you can see here, so move the x squared over, so that's 2x squared. Add 6x's to both sides, that's 6x left equals to 0. Take out 2x, so that's your greatest common factor. You should have an x minus 3 left. Take each factor, set it equals to 0. X equal to 0. Well, it doesn't make sense to make 0 products in this application. So the other answer is going to be 3. But remember, it's 3,000 units. So make sure we add in the thousands. So students, now we have a minimized cost here. So to minimize average cost, okay, 3,000 units needed to be produced. Box that up.